Hello everyone, welcome back. I am Ram. In today's video, we will improve our model accuracy by applying hyperparameter tunings with GridSearchCV. So now, without wasting time, let's go to the code. In order to apply the hyperparameter tunings, we need to import the library from the scikit-learn. From scikit-learn model selection, import GridSearchCV. Alright, and next I need to have the param grid with respect to the first one is the linear regressor, and I am giving the nothings, and then other is a reach I am passing the first is alpha value I am passing the 0.01, and then the 0.1 1.0, and then I am passing 10, and the third one is the lasso, and with respect to lasso I am passing the alpha value I am passing same, I am passing 0.01 0.1 1.0 and 10. Alright, and then third I am passing the random forest regressor with respect to first I need the number of estimator, I am passing 50 and 100, and then send I need maximum depth I want with respect to I need like to pass the nonce, and 10 I think is well 10, okay, 10 and 20. Alright, and then second, and then sorry, and then fourth is the gradient descent regressor. So here I am also passing the number of estimators, sorry, number of estimator which is the 100 and 200, and then I need to also passing the learning rate, and with respect to learning rate is the 0.5, and I would like to pass the 0.1. And one more thing, I'd like to pass the maximum depth also. Let pass this one, how the model will be trained, 3 or 5. Alright, and then 1 2 3 4 5, and then I need also the ADA boost, boosting regressor. Okay, ADA boosting regressor I need to pass the number of estimator with respect to, at this time passing the 50 and 100, and then to pass the learning rate learning rate 0.5 and 1 point, I think is 10 is fine. Okay, then I need to the 1 2 3 4 5 6 done, then which is remaining support vector machine regressor. With respect to that ones, I'd like to pass C, and here I need to pass the 0.1 and 10 is 5, and then I need to pass the kernel. I'd like to pass linear and RBF, and then next is the decision tree. Regressor, and the decision tree regressor I need to pass the first is the maximum depth. So the maximum depth is known, and I 10 20 is fine, and then the minimum sample split with respect to, let's pass the 2 5 is fine. Now regressor, and here I need to pass the number of estimator with respect to, I'd like to pass the 100 and 200, I think is well, and then I need to pass the also learning rate. Learning rate should be 0.01 and 0.1 and 0. Let's pass the 5. Okay, and then maximum depth. The maximum depth should I passing the 3 5 is fine, and then finally which one is remaining? Cat boost regressor, and with respect to cat boost I need to pass the iteration is the pass the 100 and 200, and then I need to also pass the learning rate. The learning rate I am passing the 0.1, 0.5 or 0.5 is bigger, 0.5 this way, this is also bigger step. Then I am passing the depth is depth 4 and 6 as well. Alright, so the next step I need to train the models, and I will do the predictions with respect to training and testing datasets. So before training the models, I'd like to make the model list grid, and I want also auto train score grid, and then R2 test score grid, now I am running the for loop for model name, and I am passing also the model in models, model in model dot item of with respect to my param grid dot get model name with respect to this, and I would like to store this to param. Okay, let me see it's working or not. Yes. Now if param grid search of model and param and score is with respect to score is R2, and then my cross validations is the 5-fold, and then the number of job is I want -1, and that ones I am going to store to the grid. Then finally grid dot fit extend and white rand, then dot the best estimator, so grid dot best estimator, and that one is my best model. Okay, and also I need to find out the print best parameter is my, and model name best parameter with respect to grid dot, and I need a best parameters should be there. Okay, else model dot fit extend and white rain. So this one is finally done, and I need also the model equal to best model. Okay, fine, let me see it's working or not. Okay, now I need to do the predictions with training and testing dataset. Predictions with training and testing dataset. White rain read, and best models dot predict with respect to extend, and white test read best model, where is the best models dot predict with respect to X test. Now I need to evaluate the models. Evaluate the model So my first matrix is the white train mean absolute error, white train mean square error, white train root mean square error, white train R2 score with respect to evaluate matrix, which is my, and then white train read and white train. Alright, and I need to do also with respect to testing. White trains mean absolute error, white test mean square error, white test root mean square, white test R2 score, and with respect to evaluate matrix is white test read with respect to y test. Okay, next I need to check the performance of the model with training and testing dataset. So in order to check this one, I'd like here the model performance with training and testing data set print. I would like to have the model names is the my model name okay. The first is the R2 train with respect to R2 train white train R2 dot 4f, and I need to also check the R2 test with respect to white test R2 of 4f 4 see it's working not. Okay, fine, it's working. Now I need to append the result. Appending result. So my model list append, and here I need to pass the model name and R2 train grid dot append, and with respect to white train R2, and then R2 test grid append with respect to R test R2. Now let's train this particular model. Now we have already successfully trained the model, but now I need to check the model performance using data frame, because here I cannot able to see. So I am making the data frame pd dot list of GIF with respect to my models list grid, and R2 score is my first is the train, and second R2 score is the test. Okay, fine. And I'm also giving the column name. The column name is So the first column is the model name, and the second one is the R2 train score, and then third is the R2 test score, and then I need to sort the value so to become sort the value by R2 train score, and with respect to ascending I am passing the parameter which is the false. Now let's try to understand. No, should become test. Now let's try to understand. After applying the hyperparameter tunings, we found that two models are the best ones. The first one, which one is nothing, this is a linear regressor, where with respect to training score is 85% accuracy, and with respect to testing is 86%. If I just talk about the ridge is also the same accuracy with respect to training is 85, and with respect to testing is 86%. That means the model is generalized models with low bias and low variance. And if I talk about the gradient descent boostings, with respect to the training is 89% accuracy, and with testing is the 84% accuracy. That means the model is under our fit. The per fit model is also there, the random forest. The training is 97%, and with respect to testing is 81%. XGBoost is also our fit. AdaBoost is fine, but with respect to accuracy, linear regressor is okay. CatBoost is also our fit model. Training accuracy is good, but with respect to testing is low. So from this particular model list, I found only the two models are the good. The first one is the linear regressor, and second one is the ridge. So the next video, what I am going to do, I am going to train this particular model, which one is nothing, the linear regressor, and then we will do the prediction, and finally we will deploy the model. So guys, that's all for the today. Please do not forget to like and subscribe. Thank you so much. Bye bye.